Hello Natroners, and welcome back to another episode of VFX with Natron. So today we're going to do something so exciting. First of all, you might have noticed that we're actually continuing sort of the 3D particles things, but we're probably actually going to scratch a lot of what we've already done, or scrap, I should say, not scratch, scrap a lot of what we've done, because I've ran into a limitation, and I mentioned that that's the reason I sort of took a pause from it, because I was evaluating, trying to come up with a solution. And I had this really interesting idea about using, instead of, I'll show you the problem with the tile node in a minute, because this is a problem that I ran into with the tile node. And I was trying to come up with an idea or a solution that would bypass this problem, and I thought, hey, maybe I can do it with SE. And anyway, it turned out that the solution I came up with was way more than I had originally bargained, and it's way cooler, and I think a lot of people are going to be, it's opening up a whole realm of really cool stuff that we could do with SE. I mean, SE has just jumped in what you can do with it a whole lot. It's very much along the lines of what you could do before with just shadertoy. And if you start like going this route, and we went over some of this in the past, but anyway, let's take a look at today's goal. And I'm going to hold on it. I'm going to talk over this. So today's goal is this, and you can see this is actually an overlay of the two different things. What we see in the background is actually the tile node, and it's displaying the problem. And I'm going to give everybody just a second to see if they can figure out what the problem is, and I'm going to actually tell everybody at the same time. So you'll see there's two different size, like what look like particle things here. The foreground stuff is going to be the actual goal of today's the big particles are the goal of today's thing. This is our SE noise, or it's not noise, excuse me, SeExpr version of what I wanted the things to do, and it's really cool. And what we see in the background is actually the tile node, and they're both working off of the exact same simple animation. But the difference is that, as we can see in the background one, the tile node, what's happening is all the tiles are moving their offset in time, except for if we look very close at the bottom left-hand corner of our screen, you'll notice something really, there's this one particle that is working very different than all the other particles, and you're saying to yourself, well, that's odd, why is that? Well, it turns out that that is actually the original particle. That is the original thing. All the other particles that you see in the on those background like grid that sort of looks like a wavy animation, those are actually the subsequent frames. But what the problem is that they're all offset exactly by the specific increment one time, and then they're all every other instance after the first instance of that is offset by exactly one frame from the previous, which makes it almost useless for anything other than, you know, it would be great if you were doing like a character animation and you had and you needed your character, if you wanted to do character frames, it would be good for making a frame, you know, what's called I forgot what they call them. They're like, it's a world frame map or something. Anyhow, it doesn't do us any good. We can see that all the other ones, other than that bottom one, the bottom one looks offset in time. It's like way off from the rest of them because it's animating at a different frame. Anyway, the stuff in the foreground, the reason they look all off is because they're actually using the same time offset as that bottom left one is. And we can see that the result is a plus they can do other things, which is they can also overlap one another, which is something we'll also look at. All right, so let's pop over into Natron. So here we are in Natron, and so the first thing we need to do is establish what the heck were we seeing. Well, first, we were only seeing one animation. We saw one little bitty thing, a square, and we're going to make this. Let's make our square, actually. Let's make a square. Let's add a rectangle. And we, whoops, I hit the wrong button. I'll hit a color correct. Let's hit tab. Let's hit rectangle. Click on the first one. There we go. And we'll link up to this. So we make a rectangle, and the first thing we're going to do is we're going to set it so that it's uniform in size. And then what I'm going to do is, the goal of this was to get 5 rectangular particles onto the screen. So the first thing, in order to evaluate what's going on, we're going to first divide our size. I wanted to, so that these all fit horizontally across our screen. So we're going to have 5 particles. So what we're going to do is take our 1920 here, and we're just going to divide this by 5. All right, and that's going to give us 384. All right, and we can see that it puts it down in the bottom left hand side of the screen, which we don't actually want. We want this to be a particle that works. We want all of these particles to start from the center of the screen, because it makes our lives or our lives easier for a whole lot of for a whole lot of reasons. The second thing is that we want this to be able to be animated. Now, one of the thing that brought my attention to, well, I gotta kind of step back and explain how this all came about. What I wanted was, I wanted to make an animation of particles or of the whatever we're using as our particle source, moving from the bottom of the screen to the top of the screen. And there was a reason behind this, but the reason is kind of going to be moot in the future, so I'm not going to go too in detail, because I had this whole idea for how I was going to distort it to get things to look like these particles were going in every different direction and so forth, because we were faking particles, and I wanted to make it look like they were all on different trajectories, and some would get bigger and some would get smaller. But we can do that using the technique we're going to be working with. We can do that already, and we don't even have to do any cheating to do it. So, but that's going into another video. But I wanted to point out a limitation. So what I wanted to do is, I wanted to take something and make it move from the bottom of the screen to the top of the screen. And I wanted to create 5 iterations of it going across. That was my original goal. So that is what our goal is going to be today. So that's the reason we have this block that is 1/5 of our horizontal resolution, which is 1920 by 1080. And we're going to put a transform node here, and we're going to take this transform node, and the first thing we're going to do is we're going to make a looping animation, because I wanted to just traverse up and down. I want to bounce up and down. That's what we're going to start with. And so we're going to, yeah, we're going to set a key here on frame 1. We're going to also change this. We're going to set this to 24 frames for our for how far we're going to move ahead. We're going to, for a Y, what we're going to do is we're going to set this down so that the bottom of this touches the bottom of the frame, or of our window. So we know that our size here, it's 348, and we happen to know that halfway between 1920 by 1080 is going to be 540. So if we tell this that we want to take 540 and we want to subtract 348 from it, that should, what just happened? That should give us 192. All right, so that gives us 192. Now, 192 is how far up it has to be from or from the bottom of the screen, I believe it is. So what we want to do is take 540 minus 348, and then we want to add back in 192. All right, so I think that's what should, or we're gonna do it. All right, why did that do it? Well, that brought us to the top of the screen, which, oh, it didn't do the math properly. All right, so we want to subtract minus 192. Was that right? No. All right, let's do, sorry, I'm screwing this up. 540 minus 192. Let's try that. All right, that's what it is. 540 minus 192 gets us to the top. So there we go. All right, sorry. We wanted the halfway point between it so that the top touches the bottom, but we don't want it to go positive. We're going in the positive direction. We want this to be negative 348 because I want it to start off at the bottom. So, and our 0 point is at the center. So there we go. So, so we know that minus 348 is going to bring us to the bottom of our screen. Right. There we go. Well, so then we go ahead to 25, and what we're going to do, actually, let's go out to frame 49, and we're just going to set a key here. So we'll set a key, and then we'll go back to halfway between, and we'll set this to positive 348, which will be the top of the screen, like so. And so if we hit play and we watch this, it's going to go up and down, but it's going to go up and down and then stop like a brick at the bottom. The other problem is that we want this to end at on our last frame to be, we want it to basically loop at the end of this. So at frame 49, we want this to loop. So we're going to, excuse me, we're going to set the end of our animation in here. We're not going to set the actual animation shorter. What we're going to do is set it so that our time frame loops at frame 49, so that when we hit play, we're going to basically watch this go up and down, and then it's just going to constantly, it's going to bounce, basically. But we don't want it to bounce like this. We want it to actually bounce and ease at the bottom as opposed to bounce like a ball. So we're going to go into our curves. We're going to select the bottom of our curve for the Y, and we're going to right click, and we're going to change, well, it's right click higher up so you guys can see this. We're going to change our interpolation to horizontal, which will give us basically a sine wave. So when we hit play, we can watch, and it eases at both ends. All right. So this is our animation. Now let's look at the first problem. Let's look at what happens if we put a tile here. If we hit put in a tile, we're going to run into the first limitation, which is our ROD. We can see that our ROD, when we look at it here, our ROD shows that it's been restricted to the size of our actual frame, because our ROD, it's basically sampling it. We're looking at our output, which is the size is HD resolution, but what's going into the tile node currently is only the original square shape, because that's the ROD that's feeding it. So this obviously shows us we have a problem. We need to actually get our HD resolution so that we can get it relative to this, that shape. So what we're going to do is over here on the side, we're going to just we'll put in a solid for right now, because I don't want to have to deal with our alpha channel. From this, we're going to hit M and put a merge node, and we're going to merge it, and then we're going to tell it that we want the output of this, or the result of this, to be, now we're seeing that we can't change this because of the fact that it was animated. We want to change the output of the bounding box to be B, which is our solid. And then we want to connect our tile node up to it. And now we have a tile node, we can see, is now showing a tiled animation of our animation, but it's doing it in quadrants, because our tile node, if we look at it, is broken into a 2 by 2. There's 2 rows and 2 columns. Well, 2 columns, or 2 rows and 2 columns, I think columns are, oh, well, anyway, the whole point is that it's doing the entire animation in each quadrant of this, or in each corner of this. All right. So what we want to do is we want to make it so that we have 5 across and no thing. So let's see, does that mean we want to bring this down to 1? Nope. We want to make it so that we have basically 5 rows. So we go take this up to 5, and then we tell it that we only want 1 column. There we go. So now we have 5 across. So this runs into the fundamental. This is where we're going to start seeing the first real issue with this. And I'm not going to go too much deeper than this, which is that when we apply this into the tile, it shrinks the tile node automatically shrinks our original source so that it all tiles. And there's a side of me that's like, well, as neat as that is, I really don't want that to happen in this case, because now my animation that I want to go from the top of the screen to the bottom of the screen isn't going all the way to the top or all the way to the bottom. So in order to fix that, I would have to increase the distance. And then what we run into, or we start to find out, is that when we increase the distance, well, then it increases the distance of what we have to crop it or have to tile it with, which means that the solid, the distance, the ROD, once it gets past the edge of that solid, which is HD and being scaled down to basically where these are stopping, we have to increase it, that solid's height, by the distance of however far, which is basically 5 times as big. So, and then we run into the second problem, which is not only do we have to make it move 5 times as big for the box, but we also have to make it 5 times as big for the actual black background as well, because that is also getting calculated into the tile as well. So suddenly what we start off with as being 1080 suddenly gets into these ridiculously exponential size things, which, you know, it wouldn't be so bad if we were only had to worry about it for just the white area, getting it to the top. But what starts happening is as soon as the SE or the tile node gets past that, the end of the ROD, and it starts becoming a dynamic ROD, the or bounding box, a dynamic bounding box, the problem is that it accelerates, and you'd want, and the boxes start moving at a ridiculous pace. And then we run into one other problem, which is that the tile node also works from the bottom of it, and because this is from at the midpoint, you can see that we're somewhere up in the middle. So because of how it tiles, that we have to actually compensate for the bottom as well. So that means in addition to scaling it up, we also have to scale it down. And it ended up, I wound up with resolutions of thousands of, you know, we're talking like 8 to 10,000 or more to get the thing up just to do 5 particles. And I was like, this is ridiculous. It's overkill and way beyond the scope of what we want. But that's only that if that were it, we would still be fine. There's another problem. And it didn't be, and I thought we were getting weird results when we were doing our offset particles before, because it didn't look like our particles were actually rotating offset by the quantities that we had told it to before. And I just assumed it was an optical illusion, and I was just seeing things and I was screwing up on things, but it turns out that it isn't. And we're going to look at the second problem, which is we saw in the opening animation, which was that the tile node, that this time offset node, if we watch this, if we actually change this and we set it to 1, well, when we're offset by 1, oh, come on, hit play. When we're offset by 1, it's not so bad. We can see that the tiles are offset by 1. But as soon as we go much higher than that, to something like 9, suddenly, or higher, we can see that, wait a minute, what's going on? It's offsetting the very first one, the first particle or the first object, by 22, but then the next one it's only offsetting from that 22 offset by 1. Well, that's no good to us. That means this we've offset one of them off by a whole lot, but the rest of them just remain offset by 1. That does us no good. So this is fundamentally going to be broken, and we could never have done what we wanted to do, or what I wanted to do, which was to get these all offset. So that is why ultimately this is, you can see that this is, let's just look at this, and we can see, you saw, they all snapped and so forth. And this also raises the question that we would also have to loop these things and do other things. So we'll get into the looping and whatnot in a little while. actually, we should probably deal with the loop right now because that is an important factor. Let's, yeah, we're going to put, the way we mentioned this before, the reason we see it right here, where these are stopped at the beginning because it's not time looped. This is not, we don't have this set up to loop. We only have basically 49 frames of animation and then it stops. Well, we don't want that. So what we really want to do is we want to use one of the properties that we got from there's a user, or one of the custom nodes that come down. If you get the Natron user nodes, you can get this, and it's called time loop. So if we do time loop, there it is, time loop right down here. It's a community node. And if we do time loop, we basically, all we do is we set the start frame, we set the end frame, which is going to be frame 49, and then we hit play, and we can then see that now, oh, all right, it's still, that's even weirder because that should have worked, but it's not. Great. Well, that's just a glitch in the overall system. It is actually working. It's just not. Okay, that's just, we got a cache error here. That's weird. All right, why is that happening? Let's clear our cache and back this up and play it. Oh, why are we? Wait a minute. That's not right. Did I not set the animation at the right frames? Let's see. Oh no, I didn't. What the heck? Frame 49 should be back at... What in the world is going on here? Wait a minute. This is wrong. It should be 348. There we go. And we want to go back a frame. Okay, something weird is going on here. Let's look at our original animation. All right. That's 348. We go forward, we're at the top. Then we go back to the end. Sorry, everybody, this is just weird. We were getting weird results. Natron doing its weird thing that it only does. All right, it's doing the correct thing now. Let's go over to our curve editor. Let's loop this. Interpolation. It should be horizontal, right? There we go. Let's make sure this is working correctly. Right, it's working correctly. All right, now if we go here and we offset it, it should work fine. And now it's working properly. All right, it was just a glitch in the system. All right, so if we go to the tile node now, hopefully, yes, we can see that they're all offset, and we're getting the actual animation, and it's offset the entire time. So now this will loop permanently, and we can see that that's an important thing. We need to use that time loop node to get this to cycle constantly over and over and over again. All right, so this raises the question: how do we start into this? Well, we've tackled what the problem, and now we're going to tackle how to deal with reproducing this with SE. But we're going to change something here. With SE, what we're going to do is we're going to say create an SeExpr. All right, so SeExpr. Come on, there we go. So we put an SeExpr here. We put this into the output of that into the first input. And you say to yourself, well, what are we going to use? Well, we're using an actual Natron specific. This is Natron. The Natron has built into it a whole bunch of open source frameworks, one of which is ImageMagick. And I believe that that they incorporated an ImageMagick routines so they were accessible inside of SeExpr, and there's one in it called cpixel. So if we type in cpixel, all right, we do a cpixel, and what you get with cpixel is you get the ability to take your input image, and you can do things with it, like offset it and access it through time. Which is really cool. And this is what enables us to do really interesting things. So if we put cpixel here, and we're just going to be export or using cpixel, and everything we're going to do is within it. So oh yes, the first thing we need to do is tell it what input. So there's a bunch of parameters. The first parameter is what input. Well, we're using input number 1, okay, which is also, this is one of the reasons I'm like, this is so cool, because not only are we going to have multiple inputs, but we can actually input. Remember how I was saying before, we had to make all these different inputs, or all these different types of particles. We can feed particles, or up to 10 or so particles or more. I don't remember if, I think it's 10 particles. We can have 10 different image sources going into the SeExpr, because this is a merge node of a type. So we can have 10 different animated particles automatically go into this automatically. And we instantly, inside of here, first thing we do is we tell it which input we want. So we want to take the image from input 1. All right. And the second thing we want to do is tell it where we are in time. Where are we getting our sample image from? Well, we want to get whatever the current frame is. So we put in frame. All right. And that's going to get this frame. But if I wanted to get the previous frame, all I have to do is frame -1. And I'd get the frame prior to this frame. Or frame -100, and I'll get 100 frames behind it. So that's what frame. So we're going to just stick for right now with frame. All right. Then we have to give it our coordinate system. Now the coordinates that it's going to start with are X and Y. So we want to, you can't just give it an arbitrary XY coordinate. You have to feed it the X position, and everything has to be relative to the X position. Now we're centered to the screen already. Whoops, our image, I clicked off our thing. We're getting an error because it's an incomplete thing. If we look at our original image here, well, if we looked at our original image, it was offset to the center of the screen. We're going to be, let's try and get this, we gotta, all right. We've got to tell it we want it to take the original X position. So we're going to take its original X position, and we're just going to keep it. We're not offsetting it. But if we could tell it to add to the X offset, or we could subtract from it to get our X position. And then we want to give it our Y, which is going to give it its Y position. All right. And then we have to give it, I believe there's only one more thing, which is interpolation. And I believe, I'm not 100% sure what this is. I think this may be a sampling for it, for how it's going to interpolate the movement or whatever. But I'm not sure. All we need to know for right now is we're going to use what's called cubic interpolation. We're just going to leave it at 2, because all the examples I did were with it set to 2. So this is it. So if we hit return, click off of it right now, it's done nothing. But if we go back and hit play, we can see it's just basically, it looks like it's passing through time, everything through time, except for now we've set up the fundamental capabilities for this to do interesting things. So one of the examples that the Natron documentation on this, by the way, if you're looking for it, it's actually, if you click on this help and we scroll down, we get down, where is it? It's actually right in here somewhere, where we can look at an example of using averaging the pixels. Here we go, right here, this little section right here. You can see we can average the pixels over the previous, current, and next frame by creating this statement right here. Well, let me explain what that's going to do. Basically, all it's doing is it's taking this and reusing it 3 times and assigning it to something. So in order to assign it, we have to give it a name. Let's just use P for previous, and we're going to say P equals, all right? And then we're going to put a semicolon here at the end, because that means that that's the end of what we're going to, of our statement. So I'm going to do P for previous. I'm going to copy this, and then I'm going to paste it. I'm going to hit return and paste it here 2 more times. All right. And what we're going to do is say C is going to be the current and N is going to be the next. All right. And then what we're going to do is tell it that we want to take the previous frame, and for the previous, we want to say frame minus 1 frame. And for the next frame, we want to tell it that we want it to be the next frame plus plus 1 frame. All right. And then all we have to do at the end here is tell it that we want to take the P plus the C plus the N. All right. And then we are going to divide the result of that by 3. Okay. Because we're taking 3 inputs. All right. And when we do that, we get this. And if we hit play, we can see it slows down a little bit, but we're getting the equivalent of frame blending, or like we've done in the past, or motion blur in a sense. It's not, this is frame blending, really. So we've just done frame blending inside of the SeExpr node using this technique. We've looked through time and we're averaging the things together. All right. That's exactly what we've done. We've done an average. All right. So this is where things I started to get really, really excited, because I was like, wait a minute, what else can we do with this crazy thing here? We've created these 3 things. Well, we don't have to divide it by 3. If we just tell it we want the result of it, now it's just adding those up together. Now, admittedly, the result of this is going to be above it. We could maximize this by, I think there's actually we can do max. I think we can just tell it. I think we could, if we just type max, I think max does. Nope. All right. Well, there is a statement in SeExp. Whoops. Didn't want to do that. In SeExp to do the maximum, but we're not going to use that for right now. For right now, we're just going to take the result and use it in this way. We can always clamp the result of this to get our final thing. But for right now, we're going to focus on this and what we're going to do. All right. So we don't actually want to, for the time being, we don't want to, well, we do want to create an offset. And what we're going to use for the moment is we're going to actually create a scalar parameter. And as people might remember from our previous things, scalars are various things. We have 3 different types of scalar parameters, or, well, they don't call them. We have 1-dimensional, 2-dimensional, and 3-dimensional. But they call them scalars, are one-dimensional basically attributes or variables. Positional are 2-dimensional, and color are 3-dimensional. All right. And as long as you remember that, that's a crucial part. So what we're going to do is create a single one, and it's going to create this thing called x1. And this is a variable. Unfortunately, we cannot name x1 here, but we're going to actually be going into this in a little bit, because what we're going to be using this x1 for is, for right now, we're going to be telling it that we want to use x1 as our offset. So what I actually want to do is take these additional ones and offset them in time. But we're going to, instead of this, we're going to call this, we're going to change it. Let's change it. Well, let's change this to let's think of these as if these are tiles. We're trying to think of this as tiles. So what we're going to do is we're going to call these tiles and call these tile numbers. So I'm going to call it tile 0. Okay, so T0, and this is going to be T1, and then this is going to be T2. All right, those are going to be our 3 tiles, and we're going to call it T0, T1, and T2. Okay, T2, just like that. All right. So, and by the way, if we run out of time, I promise we're going to work on this again in the next one, because this is really, this is complex. So we have frame. What we're going to do is say frame 1 is going to be plus T. Well, we're going to say we're going to offset it by 0. All right, or what? 0 times. Actually, what we're going to do is our time is going to be We're going to create something that we can represent it. So how much time are we going to offset this by? We're going to be offsetting it by 0 times whatever our original thing is, which is our x1 is going to be our actual time that we're going to be offsetting it by. So it's going to be, we're going to say x1. All right, so 0 times x1. All right, so that is going to be our time offset. We're going to just take that, copy it, and then we're going to paste that onto a frame here and our frame here. All right, and oops, we want to frame plus, we don't want 1 there. All right, and instead of 0 here, we're going to say 1 times it, or is it 1? Let me just yes, 1 times it, and this is going to be 2 times it. All right, so this is going to be our result. Now, obviously, we're looking at this divided, we're looking at 3 instances of this over time. So we need to somehow offset these as if they were, we're dealing with a horizontal tile at this point. So we want to offset these by our x dimension. So we have to figure out, well, what direction does plus and minus take it? Now remember, this is because this started off at the center. When we add or subtract to this, it's either going to move it to the left or right. But we are assuming we're at 0, 0 right now. We're at x 0. All right. So if I say plus, if I say plus 300, or actually let's do 348, because that ought to, remember, I think, was it 348 or 384? I don't remember. I think it was, oops. Oh, we did some problem here. Syntax area, blah, blah, blah. I think the problem is that we don't have a number here. So let's try that. Nope, nope. Oh, that's the problem. Isn't that we don't have a number there. The problem is that I told it x equals, not x plus. No, I didn't hit plus. Okay, didn't register my shift. The program doesn't actually show that I hit shift, or at least it didn't look like it did. Anyway, let's see. So if I do that, there we go. So we can see that when I hit plus 348, we can see that it offset it, but it offset it a whole lot more than we originally thought. This looks to me way, way more than 348. If we started at, well, is it? Is it really? I don't know. Actually, maybe we want to offset it by 192. Was it? I think that's what we said. Let's try 192. There we go. 192. Let's just make sure that it's actually 192 by, all right, we're going to say, so here's our offset in time. If we take our offset in time, remember x1 is going to be our time offset. So if we take this and we start increasing this in time by, say, 7, 8 frames, remember this is constantly offsetting it. So we can see that approximately where it is here, we can see the other 2 are offset in time. And you know what, for the time being, we're going to put in that divided by 3 so that we can actually see these sort of stacked, averaged, and we can see that, okay, so this is the edge of these 2 where they overlap, and our box that we offset, our original one offset, is to the left of them. Now the question is 192 the exact amount that we wanted to offset it by? Because this is, I don't know, it looks like it might not be quite enough. Well, anyway, so we've offset it by 192. Let's try offsetting offsetting it in a positive direction, moved it to the left. So that means if I wanted the next one to be, or this one to be at 0, we would start it off at 0, and then we want everything. We basically, what we want to do is we want to make it so that we can figure out where our left side of the screen is for the purposes of tiling. And the reason that we want to do this is because ultimately I want it to just, I don't want to try and do adding and subtracting of our tiles. I want it to start at basically the same point that most of our things start at with the tile node, which is the bottom left or the top either bottom left or top left. I think the tile node starts from the top left, but and most other things in Natron start from the bottom left. So personally, or at least I think they do. Anyway, so we're gonna basically be, in my mind, I think I want to put it in the bottom left, but we'll see. We'll see when we start adding and doing stuff. So what we need to do is figure out how far over we need to move this to get it to 0. So we already know 192 moves it off, or should. Let's, again, we're going to test this, make sure. Oh yes, we can't scroll up. So let's say instead of 192, well, we got to, let's do, well, 192. No, we do know that this is exactly on the edge. How do we know this is exactly on the edge? Well, actually, we don't know at this point, but if we go zoom into 100 and look at it, oh, look at that. It's looking weird. Okay, so this raises a problem that I thought we might be facing, which is we can see that it's not drawing everything. So this means that this particular using this technique is going to require us to draw the entire frame in order to, at all times, in order to properly evaluate it. So what we're going to do is we're going to just click on this here and tell it to force draw it at all times, the entire frame. All right, let's see what that does. Does that? All right, it's giving us an error. Let's disconnect this temporarily. And let's go back to frame 1. And this is going to take a minute to update because, all right, so we've disconnected it. Uh-oh. Well, that's not nice. Hopefully Natron just saved our entire animation, or that was unexpected. Oh well, the bane of a live stream. Let's see, we're about 42 minutes into this. We're going to wrap this up. We're not going to get around to doing all the bits of it because we also have to write some Python. We're probably not going to get to the Python bits today because we're going to, I mean, we've done the Python bits honestly in the past, but we're not going to do the Python bits of this today. We're going to focus on understanding this, what cpixel is, and how to do this sort of manually. We're going to get 5 vertical, bouncy, offset in time things, and understand and figure out how we can offset them in space to line up, and so that we can see this hopefully rendered properly. And it's opening in another. Yes. It wants to open up our previously saved thing. There we go. And hopefully this is going to not throw an error and get all nasty at us. All right, it hasn't thrown an error yet. Hopefully when we hook this up, I'm really hoping this is not going to be crushing on us. So at a 100%, things look all right. So at 100%, and at this point in time, it's not really helping us very much. We need to go ahead in time. So let's go ahead. Let's go ahead 12 frames so that we're about halfway between the movement. And I'm hoping that we'll get to see this. All right, so there we go. So now if we hit fit, I'm hoping by forcing this to draw, whoop, thought we forced this. It says that we forced this to draw, but it does not look like it is drawing. All right. You know what? I think we're gonna drop this back to 6 frames. Let's go back to 6 frames in, because I have a feeling the vertical, the 2 other copies are overlapped in time. Maybe. There we go. All right. So we can see that that now when we're telling it to draw everything, that indeed our frame, the offset 192 was not enough. It's only offset it by half the distance that we actually needed to offset by, which means that it was offset you know, we were not doing it properly before. So important note, this does not work off of screen space. And I found this out, by the way. This is a useful thing that we're going to be using in the future, is that by doing this, it forces it will redraw. And I think this also will work on gimmick nodes. I haven't fully tested this yet, but we can figure out that we can see that it's now looks like it's offsetting it correctly in space by keeping this and telling Natron, no matter what size, draw all our pixels. This is so important because of the resize bug. I call it a bug. It's not really. It's a very useful feature because it speeds things up. But in our case, we need this to be accurate. And so in order to get our mathematical calculations proper. So we want to do 192 times 2, which was 384. So we go back to 384 and let's try that. And hopefully, there we go. So at 384, we have moved this entirely 1 unit, which makes sense because that's the size of our original block. All right. So if we move it twice that, we should be able to get. Let's just do this the simple way. 384 times 2 here, just to make sure, times 2, and we should get our math, and we will wind up with this offset to the 0 point. And there we go. So this is at 0. All right. So we know in order to get the first one back, we first have to add. This is going to be what I consider my starting point. This is where I want it all to start, basically from this side of the screen. And y, by the way, is at 0. So, and if we go to 0, we noticed that this was all touching the bottom left. So we already know that y at 0 is basically the bottom left corner, as far as I know. Yeah, that's good. That makes, well, I'm not positive. Let's just be on the safe side. Let's go back to the beginning. Right? And then we're going to add, you know, let's add plus 192 to y plus 192. See if that moves the y down or the y up on the vertical, because we really want to know. All right, so y moves it down. So positive is downward. So this is starting from the upper rightmost corner, which is the opposite of what I'm thinking of. You can treat it that way. I like the bottom left because when we think of the original time offset node, we noticed that the offset was working. The one that was doing the correct thing was happening in the bottom left. So that's where my mind is mentally for this. So I want to try. We're trying to mimic that. So you don't have to do this next part, but what we're going to do is we're basically going to figure out where our offset in time is or our offsets are. So what we're going to do is basically subtract whatever our multiple, our tile set is. We're going to subtract a tile. So we want to create a variable here called tiles. I'm going to just call it tiles. And normally you're supposed to put a $sign in front of this. Whoops. $sign in front of this, and we're going to say tiles equals 5 because that's how many tiles I want. All right, and that's going to actually just be our X tile or horizontal tiles. And but first we need to take and figure out our offset, which, so we know it's 384 minus 2 divided by 2 is going to, so that should be 384 times 2 should be 960 actually. What, that should just be 960. Oh yes, we need to put a semicolon at the end of that, otherwise that's not going to work. And if we take this and we say x plus 960, which is halfway between 1920, half of 1920 is going to be 960. So this should bring us back to 0. All right, there. All right, so it's 960, and then we're half of our offset. Okay, so it's 960 plus our offset, which was 192, and we don't want this over here. Let's get rid of our, let's get our Y back up. So it's 960 plus half of our distance. All right, so again, so it's going to be 960 plus 192, or actually it's going to be minus 192, excuse me, minus 192, right? Is that right? That will put it, so no, 192 is going to be our offset for, to get it centered in our tile. So no, 960 is what we want to, offset this by, yes. All right. I'm just thinking about this. All right. So 960 is our offset. That gets us back to 0. Then what we want to do is from the 960, we want to subtract half of our overall resolution. All right, so we're going to take our resolution, which is going to be 1920 divided by 2. No, it's going to be 1920 divided by our x1, right? Yes, we're going to take 1920. We want to figure out how many tiles we have, so it's x1. Okay, which, because we're dividing it by 1920 by 5. All right, and oh right, we said our x1 is 8 right now. Well, we want it to be 5. X1 is going to be 5 because we want 5 tiles. Okay, so our x1 is going to be 5 tiles. All right, and so hopefully that should get us to there. Now we're seeing that it is, but the problem is that we need it to be minus an additional half of the x1, whatever the result. All right, so we need to subtract from this. Let's make a new variable here, which is going to be called a row. So we're going to do $row. All right. One row is going to be equal to our tiles, or actually, technically, this shouldn't be tiles. This should be rows. Let's make that rows. It doesn't really matter. Our rows is going to be that. Our rows, we're going to have 5 rows. And one row is going to be equal to 1920 divided by our rows, however many rows we have. Rows. There we go. Semicolon. There we go. All right. So if we say that that gives us our rows, and then we want to find the center of our row. So the center of our row, so we're going to call it row RC for row center, is going to be equal to the row divided by 2. All right, and we're going to put that in us. All right, so that gives us we have a few variables here. All right, so why is that important? Well, first of all, actually, we're going to say that our rows are going to be equal to x1 for right now. Actually, that's going to even be better. So now we know that rows are, this is x1 is our rows. So that we can sit here and we can say 1920 is going to be our divided by our rows. Right? That should get us back to here. And then it's going to, then we're going to minus or subtract from that an additional, let me see. So 960 minus 920 divided by rows. And then we're going to subtract from that our row center, the center of our row. All right. I think, hold on. No, we want to add to it our row center plus our row center, because we want to move it back in this direction, which is a positive value. All right, let's see if that works. That should, hopefully, if everything worked out right, we should wind up with this back in this left-hand corner. And we are. So there we go. So we've got added our the row center to it. So this is our left-hand side of the screen. This basically, let's actually do it slightly different. Let's take 960. Okay. So we take our 960 and then we add to our 960. Our 960 puts the center of this at the offset to here. And then what we want to do is we're going to add to it the row center, which is actually going to push it in the negative 1 unit. And then what we're going to do from that is subtract from that the not double negative. We're going to subtract from that the rows, the 1920 divided by our rows. So that will take our rows, the horizontal resolution of our entire screen, or our output resolution, and divide it by rows. Now we're going to get this output resolution at another point in time, but for right now we're just going to manually set it. So we're dividing it by our rows, which is 5, which we set up here. It's 5. So we're dividing 1920 by 5, which is going to push it, offset it by 1, and so that winds up, that should give us exactly the same result, and we'll just wait for this to offset. And so hopefully, is that right? Is that right? All right. Yes. There's one more thing we're going to do. All right. We're going to put rows here inside of parentheses, and we're going to tell it what row we're on. We're on row 0 because this is our first row. It should be basically the same. Our row number is going to be what we're going to multiply it by. All right. So we take this. We're going to take the cpixel here and copy that and paste that here. I'm sorry if this looks cumbersome at this point, we're just trying to get it so that this is going to work. So now what we're going to do is we're going to say frame, this is going to be frame offset is going to be by 1, and then we're going to offset it by 1 times that, and then we're going to say rows, this is going to be row 1. Correct? Let me just think about that. No. We're off by 1. That should be row 1. This should be row 2. I'm just thinking about this. Because we want rows times 1 is equal to rows. Rows times 2 is going to give us 2 times whatever the rows is. Yes, that's what we want. We want row 1 is going to be this row. Row 2 is going to be this row. Row 3 is going to be this row. So this is going to give us, when we go over here, let's go back, let's paste this in here. And then this is going to be row 2. And then this is going to be row over here. This is going to be rows times 3. So that's going to be our 3rd row. All right, let's see if this works. We should wind up with 3 in a row. Hopefully offset in time. Wait a minute. I'm an idiot. We did the wrong thing. We want 2 scalars. The second one is going to be our time offset. The first one is how much time we're offset by, which was whatever it happens to be. We're just going to leave it at 5. We want to All right, so the reason this isn't working is because this should be, if I'm not mistaken, we have more than one problem here, actually. Let me just think about this. Should be x2, first of all. But secondly, we have a problem here. I'm doing the math wrong. And everybody's saying to themselves, what are you doing, Pirate Bill? This is all... You've got it right in front of you. Start looking at the stuff. All right. Got to pull up the actual code here and look at something. All right. So what I did in the real one is I took it. Let's create a thing. We're going to create a bunch of variables. We're going to create a variable called tiles. All right. And tiles is going to be equal to -1. All right. By default. Then we're going to create a thing called offset. Also an offset. And offset is going to be equal to this is our time offset. Offset is our time offset, so that is going to be equal to x1. All right. And then so that's going to come from here, our time offset. And just so that this is what is going on here? Why are we getting... Oh, whoops, we didn't put a semicolon after that. There we go. So if we go up here, just to make sure x1 is different, we'll set this to 9. All right, so that's our time offset. It's going to be that. Now, and then we're going to make rows. Rows is going to be x2, right? Columns, we're going to make another thing called columns. $ columns, which we haven't decided. Calls, it's going to be calls. Yes, calls is going to be equal to, well, we don't have an x3 yet, so we're going to be, but we'll put it here. We're going to say x3 semicolon, and we're going to, for the moment, we're going to just put a hashtag there so that that's commented out. Then we're going to create a width, which is our screen width. So $W is equal to 1920, semicolon. Our screen height is going to be $height equals 1080, semicolon. All right. And then we are going, let me just get a couple of things. We have, all right, row. We'll do the rows. Row we're going to be dealing with slightly in a little bit later on. All right. We're just going to put a couple lines there. We need to get our... Okay, so actually what I did, I take it back. Let's, for the moment, we're going to comment these ones out. We're going to comment all of this out. No, we're not. We're going to change it. We're going to change it. Instead of this being row, this is going to be R. R is going to be the W, which is our width, divided by our rows. And we're going to actually change it from rows to R, because that's actually how I had it in my code. So we're going to change these where it says rows here to row. Is that right? Well, we're going to be redoing this math. All right, we're going to just get rid of this for right now, and I'm going to go back through it because I apologize. We're just going to put R's. I was trying to take a shortcut and it bit me in the bum, as usual. As usual. Poor Bill does something wrong way. All right. So there we go. Plus, it doesn't have anything, so it's not going to add anything. That's fine. All right. So So offset, we want to change the time, the frame. We're going to change this to offset. So we're going to put in offset here. And we're going to just copy that a couple times. Offset, offset, right like that. All right. So we can see that that does our time offset. And this isn't updating. Oh yes, because we haven't moved out of it yet. So R is our width divided by our rows, which our rows is set up there. All right. And let me see. There should be something else. I'm missing something. Oh yes, R is rows, and then $C is our columns. That is going to equal our height divided by our columns. Okay, semicolon, and that also I don't think we need right now, so we're gonna just do a hashtag there because we don't have a columns value. All right, and then we want our row center, which is our RC, and we also are going to want a column center. So we're going to do a $CC, column center is going to, and that's going to also be hashtagged. We're not going to worry too much about a column center, but a column center is going to be our, let's see, wait a minute, it's our RC is going to be our row divided by 2. Leave. Yes. Yes. So, right. I think that's correct. I'm not positive of the math yet because I'm getting these things from two different areas at this point. So some of the stuff is actually coming from Python and I'm translating it as we go. So I apologize. I was trying to rebuild the original, what I thought was the stuff. And anyway, it's a little complicated. So the column center, we're going to just, for right now, it doesn't matter. It's just hashtagged, but that's going to be, the C divided by 2 as well. All right. That should get us the center of those. And I'm not positive about these. Let's just do not pause and hashtag not pause, not pause. Terrible. That way know that I'm not positive about those two. All right, so why did we do this? Because according to the information in my thing, what we want the math here to be is we want it to be, let me make sure, 0 is going to be, I just need to verify I'm getting the stuff right. Tiles. This is going to be easier if I do, something broke. What did I break? Something I did broke. Oh, it's probably these. Plus 0. Let's just do 0 for right now. 0. Let's try that. See if that fixes it. It's saying 1 times offset. Frame plus 1 times offset. Frame times offset. cpixel. Could be. Maybe it's because I'm doing... Did I type in offset wrong? No. Offset equals x1. That's correct. Guess we might need a $sign. So, nope, it's still giving us a problem. I did something wrong. Oh boy! Oh! I see what it is. We've got double parentheses here and here. think. Is that right? No, we need double parentheses. That's why what the problem is. Double parentheses was missing. There we go. That should fix it, right? No. Hold on. Let's see. One parenthesis, two parentheses, nope, nope. All was right the first time. Where we have double parentheses when we should only have single parentheses. There we go. And there we go. All right, so now it's calculating correctly. All right, sorry about that. Just needed to get that straightened out. So there we go. They're all overlapping. We can see our offset is set. So now, let's see, what time is it? It's 1 hour and 10 minutes. We're going to just wrap this up real quick. We're going to get these things in here. Let's get those times. So we've got a frame. We've done 0. We did 0 times our offset. Then we do, and our offset is going to be our actual time. Oh yes, the tile. The reason the tiles is set to -1 is that we are not going to actually. We're not actually going to be using this variable here in here. Normally, what tiles is it's a variable from in Python that's going to be setting up our T0, T1, T2, etc. When we get to it. But we're not going to be using it here, so we could technically comment that out. It doesn't matter. It's not going to hurt anything. So we don't need that at the moment. But what we do need is I need to get math that got me the 960. We need this to be basically what we need to do is we need to get our we need the x to be plus, let me put it this way. What we want is 960 minus 192 is going to be is that right for x? That doesn't seem right to me. Yes, 192. All right, so it's what our result is going to be. It's going to be 192 minus x, or 960 minus 192. Then it's going to be plus 960, which is going to be our offset, or how far off it's going to be. So basically what we want to do is get our height, our width divided by our height, which was, where is that? Do we have that as a variable? So what we're going to do is right here, basically what we want here is our width divided by 2. Now, did I do that anywhere? Width divided by 2. No. So we want our width divided by 2. That is what we want. Width divided by 2. All right. That gets us our offset. That's how much we're going to offset. We're going to add that to each one of these to get our initial offset. Okay. So you're saying to yourself, why would we do that? It's basically going to give us 960 in this case, because ultimately the width is going to change based off of our resolution. We need that to be a dynamic variable. And so that has to be set via something that is dynamic, which we can't do at the moment. And I'm seeing an extra, all right, we've got an extra parenthesis there and an extra plus there. We don't want that. So there we go. So that is our offset. That is going to be our positional offset to reset it so that everything, if we click off of this right now, everything should move over to 0. So everything should be halfway through. Except for our first one. Oh yes, because our first one, we already are doing the 192. So how did we get this 192? Well, the 192, I believe, is going to be our... we are going to take our position. To get this, we need to, I got to look at the original values of this. So I want to take the, this was a lot more complex. All right, we're going to create a parenthesis, and we're going to take the row, and we're going to add 1 to it. All right, we're going to add 1 to our row. So row is currently should be, what is row? We don't have a row. Why don't we have a row? Because row was created, okay. Okay, row is a variable. Okay, so what row is, we need to create a row temporarily. Row can't be made here because row is, okay, row is for our purposes at this point, because we can't row. Okay, row in the final thing in our final animation is going to be an incremental variable. It's going to basically be a count. So we can't do row here. So we have to mimic the math for row. So I need to do what it's going to be is it's going to be whatever position we are, which is going to be 0. We're position 0 plus R. Oh no, it's 0. Let me just think about it. Hold on. It's a 0. Right. It's actually our position is 0. It's going to be our row position is going to be 0 plus 1. All right, that's what it was. Because our initial 0, because this is going to be working off of basically the equivalent of most array math, where our first unit is going to be 0, we need to add 1 to it because we want it to be add 1. We want to get a result of 1 from this because for the multiplication. So we're going to be doing -1. Okay, so it's 0 plus 1 for our first position. This will make sense, hopefully. And then we are going to, from that, row plus 1 times R. Is that right? Times R. R is our row. Correct. That makes sense. All right. So our row position is going to be where we are. We're row position 0 is going to be the first one. So we add 1 to it. So we wind up a position at the first position, which is 1 plus R, or times R, which is 1. So 1 times 1 is going to be position 1, which is going to get us here. So that should do 192. So, okay. So that is our entire expression for the x. So let's just take that and copy that. And we're going to paste that in here as well. But the difference is now, instead of this being position 0, this is position 1, which means this is also position 1. So we can see it's position 1, and position 1. And then for the last one, it's going to be the same thing. We're going to just paste over this and change this so that it's position 2 because it's T2. So we say it's position 2. And then here it's going to be position 2. There we go. Plus 1, which will bring us to position 3. And then we take it, and when we do everything, if everything worked right, why is that not coming out correctly? What? We have something that is off. Aha! Up here, I believe we need an additional parenthesis. Let me just make sure. Yep, we were missing a parenthesis. There we go. And there we go. So, but we are off. We are off. We are off by exactly 192. Which is weird to me because that's what I got in my original one. Well, wish I could tell us why we're off by it. Let me just take a look at this. width divided by 2. And look at this. Let me look at the math here. Okay, where is that math? So 0. X is 2 minus 3. 2 tiles 2 is offset, so 2 is the offset. Offset is wait a minute. No, 2 is W minus 2. Excuse me. So it's a width divided by, no, W divided by 2, which is a width divided by 2 minus 3, which is our row, times R. Oh, it isn't. We're not done with this. Haha. We're missing a bit of R. We're missing the last bit. This is the crucial part that I was missing. Aha. I thought I'd gotten to the end of it. Minus, we have to subtract from this, each one of these, are R divided by 2, which is R divided by 2. Okay. So what is R divided by? Well, we know what our R is. Our R is the halfway, or is the width of each one of these rows, right? R divided by 2 should be, so if we take this and we put the minus 2, R minus 2, there we go. No? Why? What happened there? What did I do? Oops, I missed the parenthesis at the end when I was copying it, and so it's missing it here. So this one, whoops, wait a minute, parenthesis there, and parenthesis here. All right, now it should work. Now we should get a perfect thing. Nope. What did I do wrong? Oh, boy. I think the problem is that we wanted to, let me just verify this. I think I see. Oh, I know what the problem is. The problem is that I'm doing that in a something. So we need to actually isolate this. We need to put that like that, I believe, because otherwise. Oh, no. We don't want to isolate that. 1 second. We want to. Wait a minute. I'm going to back this up. I hope. Okay, I think I'm back to the beginning. All right. We want to take and isolate this part right there, because that's what we want to subtract it. That's 3. So the problem was this: I had an operational order problem. I wanted to subtract the result of all of this from W divided by 2, which the problem was it was doing due to order of operations, we weren't getting the proper result, so it was doing the wrong thing. I think this is what's going to do it. I hope. Yeah, there we go. All right, so there we go. Now we've got our offset and everything works. So it looks a little complicated. I apologize. It took a little bit, but the goal behind this is that now that we have this here, what this means is as we increase the one that represents our divisions or change this, this will change dynamically. So if we do this by 4, this hopefully, I hope, if everything worked right, will offset correctly. So we can see that we can change dynamically how many tiles we have. So now that we've set it to 3 tiles, which is actually how many tiles we have, we can see that the tiles are offset by exactly 3. It's divided perfectly into 3 perfect offsets, well, relatively speaking, and they're 3 perfect offsets with a black border. If we put a black border at the dead center of between these two blocks, we can see that there's a little bit of black border on this side and a little bit of black border, which is why there's less black border over here than there is between these ones. But they're all offset. Basically, each tile is perfectly offset. So there we go. We've got our offsets. This is a perfect 3-tile offset. But we want to do 5 tiles. So we're going to set this back up to 5. So how do we fix this so that it's 5? Well, all we have to do is expand this a bit more. But all we have to do to expand it is basically take this. Now, this is the problem with this. Ideally, what we would like to do is make something that automatically constructs this, all right, where T is automatically created. And unfortunately, SeExpr does not allow us to do increments, but Python does. And this is the reason we're going to be going into Python in the next episode. But so we're manually, for right now, what we're going to do is create the remaining 2 of these. So we're going to create another 2 more of these variables. We're going to, by just copying it and pasting it. And then what we're going to do is change it so that this one, instead of being T2, this is going to be T3. And then everywhere we see a 2 in this one, we're going to change it to 3. So 2 there. Well, not everywhere, but everywhere there should be a 2, which are those 3 points. Okay. And then this should be 4. That's the screen width divided by 2. 4 and 4. All right. So it looks a little weird here because that's actually going to be our row. These are our rows. So we're taking our row and dividing it. So we're in row 4. This is row 3, row 4, and this tells us we're in row 3 and 4. So right here, what we want to do is we want to add in plus T3 plus T4, and then we could say divide this by, instead of 3, we can divide it by 5. And now we should, whoops, what just happened? Something did not get done correctly. Where did I make a mistake? Oh, wait a minute. I see what the problem is. That shouldn't be there. Pasted 2 things in that shouldn't be there. There we go. T4. I had copied this line beforehand, so it made an error, so people know. And there we go. This should give us exactly 5, and they're going to be offset in time. And so we can see. All right. So this 9 is how many frames. This is our time offset. 5 is how many blocks we want, how many tiles we want. We know that this was divided. Our original goal of this was to get 5 blocks divided across it and being offset in time by 9 frames, all right, or by whatever we say. If we want it to be offset by 1 frame, we put 1 frame in. So this will offset it by 1 frame. Let's take a look. Does this offset it by 1 frame? And there they are. They're all offset by 1 frame. Now, right now, we're looking at these as all gray. And the reason we're looking at them as all gray is because we want to make sure that they're not actually overlapping one another. So we can see we've created a time offset. We've created our time offset that's user controllable, and we can offset this by however much we want, although it really doesn't matter. If we set this to, 9, oh yes, and there's one other thing about this, which is that's an improvement is that we are not only restricted to doing whole numbers. With the original tile node, we were restricted to doing time frame offsets by whole time or whole frame numbers. We can actually tell it that we want to do this by 9.5 frames. And then we'll see that this all should offset just ever so slightly. And there we go. We can see that that changed it. So this is actually improved over the original one, over the tile node, in that we can get actually fractionals or floating point values of it. So we get all the benefits of the original tile node trying to go across. Plus we're going up and down. Excuse me. And we're seeing all the things, and we haven't scaled it, so we're getting all the vertical. But you say, oh, part of Bill, we're getting all the vertical, but we haven't shrunk it down so that if we wanted the particles to be smaller, we want them to be smaller. Well, guess what? Of course we don't. We don't want to actually control it by our tile node. We want that to be controlled back here at our transform, by simply changing our transform back down to something smaller, like, oh, 1/10 of its size, or let's even make it just 1/4 of its size. Uh-oh. We're going to tell it, no, don't do that. We're going to let it go. I'm hoping that this didn't crash on us. There we go. It didn't. That basically meant that Natron couldn't keep up, or it was doing a process and we had changed a variable and it was getting an error before it was finished. But as we can see, don't by the way, don't scrub through your things with the time, with anything that does what we're doing here. Physically change them or pause your render and so forth. But we can see by changing the size, we can shrink our physical scale. We're keeping our animation the same size. And now we're getting the same, we're getting the ability to do our array tiles, as many as we want. So we've made it 5 tiles here. And we could change it to, well, if we make it less than 5, we're going to wind up with the last one. Could look weird. We might wind up with some, weird math and things going wonky. But we can see that they're offset in time. And so, admittedly, this is going to take a little while to render. But we can see the end result. And we're not going to change it anymore. Oh yes, there is one thing I do want to point out regarding this. We'll just back it up. We can see that they're all offset in time exactly by the amount I wanted. So what I've done at this point is I've created a tile system, or something that could function as a tile system inside of this that's offset, and that we have controls. We have 2 controls that we can use, and just by incrementing our basically our column number or our row number here, we can get our actual position in time and so forth. And I think we're not gonna go into doing the Y values at this point, because the Y values are literally all we're doing is basically taking this exact same routine and we're applying it to the columns, and we're just dividing things instead of dividing it against the width and the row. We're dividing it against the width and the column, and then we're dividing it by over here we're dividing it by each individual column. And that will wind up with wherever the position is. And this number over here is actually going to be, this is what is actually going to be our tiles, which is why tiles is set to -1, because tiles is just an increment. It's actually not actually in the ultimate expression. When we actually go into turning this into true tiles, we're going to need it to, we're going to just be creating a consistent number from 0 up to however many tiles we have. But so the tile is going to be consistently increasing, but then tile 5 won't actually match, because won't actually match the row that we're in as it currently does. That's why we're keeping it at a row at this point, is because so we can see the math. When we get into doing column math, then the row is going to be different, because the row, obviously, if you have something in a row in the same row but in a different column, it's going to still be a different tile. But it's going to be 2-dimensional, if that makes sense, 2-dimensional positions. So I didn't want to get into that because that's beyond the scope of today's thing. We're going to actually, what I really want to focus on right now is I wanted to focus on the tiling and how we get the tiling to work. All right. So we can see that this works. And ultimately what we're going to be doing is we're going to be creating a Python script that's going to control this stuff. And we're also going to be transferring control of all this stuff from these stupid parameters that we're using here that are labelless to actually intelligent labeled parameters. But we're going to do that in the next one when we get into Python, because we're going to actually do this very different than the way we did it in the past, because I want to make a single node that does everything without having to resort into going into groups. And there's a good reason we're going to want to do that. We're going to be able to make this. I'm very excited about this. Very excited. Anyhow, we've gone on for, holy smokes, over an hour and a half. This has been a really long episode, and I apologize to everybody. So today's goal was this, which is sort of, we're on our way there. We're halfway to this point. This is really complex, but I hope we're seeing where we're going. Anyway, I wanted to just say thanks for watching. Keep on Natroning.